All right. Hopefully everyone can see the screen. Okay, good. It's client-side A/B testing, and I want to give a brief primer on this topic, in case everyone is not up to speed on that. There were a couple of discussions in the performance working group last year about this, but client-side A/B testing generally refers to making changes to a web application related to A/B testing right on the browser. And I call it a cosmetic level application because usually these changes are not integrated to the primary source code, and it could be from an A/B provider, but the key differentiator of this method is actually that most of it gets applied on the browser using a client-side scripting, and usually it's JavaScript. And because we are using JavaScript, it usually has a performance penalty associated with it, which is why it's of interest to this group. And that happens because the script has to be fetched from the client and parsed and executed. And if we do that in a blocking way, where we are actually blocking the rendering, that actually incurs a penalty in the first rendering of the frame. If we don't do that, what usually happens as a side effect is the unmodified or un-A/B tested control document is visible to the user, and they might start interacting with it, and then the script would be modifying changes. So that could also be a very jarring experience to the user. Neither of these are actually great outcomes, but this method is very popular and very flexible because, one, it actually is very friendly to external teams like marketing teams or product management, who's not directly having access to the engineering resources. The second thing is it actually saves a ton of resources in implementation right inside the code base testing with the primary team and redeployment, and also when the tests are done with, somebody has to clean up all of that, which actually so this method actually somewhat helps to reduce the tech debt introduced into a code base as well. So it's very popular in the industry. The other notion is that even for and this is actually from a point of view of why this is a great problem to solve. Even for teams which are actually doing server-side A/B testing, solving this the right way could actually help them offload some of their more cosmetic and not like full stack changes to this method, thereby saving effort and cost required to do A/B testing. And that also usually translates to more tests, which might be beneficial for teams which are actually doing active experimentation. This is a recap. We had, again, like I mentioned before, 2 sessions which were recorded, and I've linked them out on the deck. And we have a general consensus that we want to do the same outcome, but minus the performance penalty if possible. The key thing that I found was there are a few ideas and directions emerged out of that call, and they were kind of a common theme. And some of those were, can we standardize the language used for these transforms? And the other one was could we use CDN or Edge or a compute-capable CDN as an integration point, which could be in the network, but it could be any proxy for that matter, but CDN seems like a great point. There was also a question about, could we just block rendering and allow parsing of script? And there is something related to that also coming up later in this deck. But those were the common themes that came out of it. There was a little bit of a debate about, do we need this transformation language to be JavaScript, or could we have a more fine, granular defined spec? And that was basically what I could find from those 2 sessions. And where are we now? So we tried to have a prototype, and I basically took some of those ideas and explored how that would function in the real world. So we have out of that experiment, we have a initial spec of a sort. There probably is a rough sketches of that. And we have a prototype that actually shows some of these concepts in action. And now I'm at a point where we could potentially take a few directions from here, and that makes it a great point in time to actually come back to this forum present the learnings and maybe look for further guidance. And that's the idea of the presentation today. So into the details of it. So if we were to visualize an A/B test as a control document with a series of transforms, this goes back to that same transformation language. So we're modeling an A/B as a control document and an ordered set of transformations. And these transformations are expected to be idempotent, which means that if you apply them multiple times, there won't be any unintended side effects. For example, a list, and the user navigates away from an index page and comes back to the home page. If the transform has to be applied, and it doesn't just duplicate the list of items. So that kind of check needs to be necessary in these transformations. We don't define that in the spec how it needs to be. We're just defining that it is expected to be idempotent. The second thing is that we broadly classify these transformations to be of two types. One is pre-UA and one is on-UA. A pre-UA refers to transformations which are best applied before the browser has a chance to parse the document. So typically that would be equivalent of a server-side transform or a pre-browser transform. Some good examples are, let's say, swapping out a style sheet. That's best done before the browser has a chance to parse the document. The on-UA transforms are those transforms which are best applied on the browser. It could be because you're approaching a DOM element that was created using JavaScript or client-side scripting. Single-page applications actually fall into this. A lot of transforms actually fall into this category. Now, once we have those two things defined, what is remaining is a way to apply this in a performant way without any measurable performance degradation. With that, so in the spec that is linked out in that earlier slide, which is actually all of this is actually in the open source right now and linked out, so we can examine that later. But this is a very early draft of what would a transform look like. So I try to serialize that into a format where we have a list of ordered set of operations or transforms. The first one is a flag that actually defines whether it's a pre-UA or on-UA. And because it's a bit field, we can extend this further, let's say, with other types of operations as well. And then the next field is actually a selector. That is a typical CSS selector that looks for an element to target for transformation. And then an operation and a payload. We'll see an example of this in the next slide. But these two are supposed to be variable based on what support we add into the spec. Now, these are some of the changes modeled out in that spec. For example, the first one is actually to change the body background to a different color. And we want to do that by appending a style tag into the head of the document. And this is marked as a pre-UA transform by this one, so that it's done before the browser parses it. And this also is a potential method to increase cacheability of these transforms, that now we could cache something after the transform. The remaining three are actually client-side or on-UA transforms. Change the title of the page to a different H1. And then placeholder text of a text box. We want to change that to what would you like to do today? And these are actually from an example that I'm going to demo, so this will make sense as we see the demo. And the last one is actually change the first item in a list to red. And these are done purely to show how the transformation spec would look like for some of those common changes. Now with that, this is more of a prototype. Now we are transitioning into a prototype where can we see this in example? And here we're trying to make use of a compute capable edge. And for the prototype, we're using a Cloudflare worker, which actually proxies the request to origin. And is the sequence diagram of that. So the page request comes in to Cloudflare worker, and it federates off two calls out, one to the origin to fetch the control document. And parallelly, it's federating an AB configuration fetch. Now, in real world, that AB provider could be one of the AB testing providers. But for my prototype, I'm actually making use of a Git-based mechanism so that it's easier for me to deploy changes and see this in action without redeploying. So what the edge compute node, which is the pre-UA phase, would do is, first of all, it applies all the pre-UA transforms. And once it actually gets the configuration, it figures out if there's an A/B test in progress and selects the request into that. And once the request is selected into a particular experiment, it would apply the pre-UA transforms and then packages all the remaining client-side transforms back into the response and sends it out. And that piece of code, along with the transforms, is actually injected into the head of the document, which we'll see why it's important to inject it into the head. And then the remaining work happens on the browser, and all on-UA transforms are applied on the browser. And this is that piece of code that I talked about, which is basically enabling us to apply these on-UA transforms in a performant way. And the key to doing that is actually, one, the script is injected into the head of the document. In the industry today, it's basically both approaches are sort of recommended, and some providers recommend to apply them to the head. Some actually pass the body. But in this prototype, we are actually injecting that into the head. And it uses a mutation observer. And I've linked out the code right on the deck. It attaches a mutation observer that listens to all the changes on the DOM. And that's the only blocking line in that prototype. Except for the parsing of the script itself. Once that is done, the rest of the work happens asynchronously as the browser is creating the document as part of parsing, and also when JavaScript is making changes to the DOM. Now, each matching element that, in the UA selector, whatever CSS selector is actually matching as it's finding the mutation records, it actually passes all of them through the supplied transform function. And these transform functions are currently JavaScript, and which is one of the things that I want to open for debate, whether that looks good or do proceed towards a more finely grained spec. This is the general architecture, sort of a diagram of how the prototype is put together. So we have Cloudflare Edge Worker, which is actually doing intermediary work. And internally, Cloudflare uses a HTML rewriter, which is based on a low latency HTML parsing code. And to mimic an API provider or an AB provider, I'm reusing GitHub just as a configuration provider. And you can see that later in the prototype, what that looks like. So to the demo. So, sorry. For creating a demo, I actually chose To-Do MVC, which is a React-based to-do program. And that actually looks pretty much like this. And this is being sourced from the actual To-Do MVC website. And because, so what it allows to do is, again, first of all, architecturally, this is a single page application. So it all boots up on the client. There's very minimal server footprint. It allows to create items, second item. And I think that's pretty much the application. So what we want to do here, so this title of the document is created in JavaScript along with the rest of the application. So we want to change some of these things which are created in JavaScript. So in order to make that happen, I created a test configuration. And this is basically the GitHub gist that actually is powering this A/B test. So we can see that we are fetching document from To-Do MVC examples React. We're creating two variants here, and both of equal distribution. The control actually is injected with a couple of headers to make the page functional, because this is being sourced from a different domain, and it actually is very similar to a marketing team applying A/B test, although in reality it won't be this bad. Because the team would have the same domain at least, but here as a prototype, I'm actually hosting it on an entirely different domain. So which requires me to put a base tag so that the relative URLs continue working. And also, I wanted to inject a canonical URL so that the prototype doesn't become, indexed as a duplicate. And then this is the test configuration, all those changes that we mentioned, which is we are injecting canonical here again, base tag as well. But these are actually the A/B tests. Like, we want to change the background color to beige. We also want to change the heading, and you can see that this is actually JavaScript, which actually gives the ultimate flexibility. But there are two problems here. One, the language between the pre-UA and on-UA is not the same. And that was done deliberately in the prototype so that we could figure out what is the best direction. I mean, we could unify them, except, CDNs might not be providing arbitrary JavaScript execution on the workers, for example. Anyway, so back to that test, we have 3 changes to be made. The title has to be changed to A/B test H1. The placeholder text would need to be changed to what would you like to do today. I think in the control, it actually is what needs to be done. And then we have more of a ongoing test, which means that as folks are adding to-do items, we want to keep the first item color to be red. So if somebody deletes the first item, the second item becomes the first item, and we want that to be colored red. And that's the ideal method of doing this is probably using CSS on the page. But we chose this as an example so that we can show that the mutation observer based approach actually continues to monitor for changes and reapplies them. And this is very analogous to what the A/B testing industry does today. So anyway, the demo is, so I created this worker which is deployed on Cloudflare right now, and we are picking that particular example that we discussed about, which is just fetching directly from the GitHub. And I created a forge parameter so that we can force ourselves into one of these experiments. If you don't use that, it would automatically select one, either control or test for you based on a random function. So in order to test that, let's try. So we can see that we just apply force equal to 1. Now you are in the experiment. And we can inspect. First of all, the first thing to notice is that we didn't block the page. There is no flash of un-A/B tested content that showed up. And the way it worked is, you can see the style tag was injected directly on the pre-UA phase. So even before the JavaScript booted up, this line is already there. That pre-UA also injected the script tag, which is the small piece of code that actually hosts the mutation observer, and then the serialized JavaScript functions, which are applied right now as on an ongoing basis. Now, if I close this and I add items, see that item 1 actually turned out to be the right color that we want in the A/B test. Item 2, if we happen to remove the first item 2 is applied, that change is applied on an ongoing basis. That's pretty much, it's a very simplified demo. It probably doesn't represent the real world A/B test, but hopefully that makes the approach clear. As for performance characteristic, the prototype actually is not showing any type of performance metric degradation. And out of the repeated test, there is a little bit of a computational overhead, and I'm assuming that more the complex the page is, it might actually have a bit more computation to do because the mutation observer-based approach. But for the most part, this is doing much better than what we are able to see in the industry right now. And we'll see why that is able to do and which part of this actually makes it possible. And if we see the WPT comparison, which is linked out here, most of the performance metrics are actually on par. I mean, there is a little bit of a noise that's created from WPT, so one of them could be either faster or slower. But in repeated test, at least with the simple test, it's not showing much of a performance. So that makes it a very promising approach, at least from a start. Now, what are some of the key lessons here in this? The edge and the CDN-based approach, and that's one of the reasons why it's able to perform faster, because of the parallel federation of control and the AB provider thing. If we were to do that in the browser as it is done today, it is still somewhat sequential. So this is sort of a unique approach to, I mean, it could be any type of proxy, but as long as we place something on the network, and CDN seems like a great place, at least for this prototype. That's one of the key things that actually makes it faster. And second thing is these transforms being available prior to rendering the body is actually key to making the document performant, which actually means that the head injection is what we should aim for. The other thing I learned is CDNs don't allow arbitrary JS execution. So that was one of the reasons why the language looks different between pre-UA and on-UA. Ideally, from a spec standpoint, we would want the same language across both, and that makes it very portable. So if one place cannot apply, it can be transported to the other. Now that brings us to the next steps. Where do we go from here? We have a couple of options. One, we could standardize the transforms further and away from JavaScript, because a lot of feedback I received during the prototyping was that we don't like JavaScript being on the, because we're integrating a third-party JavaScript directly onto the page. It is somewhat analogous to what AB industry is doing today, but at the same time, we could move that through more standardization to a fine-grained spec, like a set of operations. There was another option that came up in the February 2021 session we had, which was basically using mutation records as one of the means of standardizing it. And that's actually a viable possibility. The caveat with that is that making it fine-defined would make the transforms a little bit more verbose. The applicator code would grow because it has to take care of more conditions. We could solve some of that problem by moving the applicator implementation into the browser directly. So that's one option in front of us. Also, like, what is the right balance between flexibility and security? That's one of the things that I'm looking forward to, like, as a feedback on where do we want to go with that. The other option is that the edge, the intermediate layer that we introduced, we could move that line close to the browser or close to the origin. So what does it mean by origin? It could be a web server plugin. It could be a connect middleware that actually works for an Express server. It could be something very attached to the origin. It doesn't have to be a CDN, because CDN is also kind of asking for a architecture change in at least one time. The other one is that we move some of that to the browser, but that will have a little bit of a performance penalty because the browser can only fetch the AV configuration after it sees the document, whereas in this prototype, it's a parallel fetch. The third one, that is a newer development, which is we're introducing there is a spec in progress, and I've linked out to the details of that, a blocking equal to render specification that's coming out in the browsers. And that could potentially help us to deploy the same thing, maybe without the edge, or maybe a combination of edge of that. But that would block the page rendering, but still allow document parsing. So even with the current AB implementation in the industry, adopting this particular blocking equal to render would be a significant benefit. I think that's pretty much all I have. So mostly looking for guidance on do we want to see more things in this prototype, or which direction we should proceed after this. Thank you.
Yeah, let me stop the recording and can start discussing.